Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izwani binti Kamarul Zaman and my team group is Daniel Izzuddin bin Hanafi and Hadira Hanis binti Syukur. We are from group 2. We would like to present about work progress and the title of the presentation is Connected Visor. For the introduction, in the fights against COVID-19, we recommend the following preventive measures such as wash hand regularly for 20 seconds, do not touch our face, keep a social distance at least 1 meter, and so on to avoid from the COVID-19 virus. We decide to build a tools named Open Source Connected Visor. User will able to protect your face, keep a social distance of 1 meter, and monitor his body temperature.
The problem statement is, the first one is the manual visor is simple. Second is people do not know the distance between each other, and the third one is people keep touching their face. The objective of this project is to produce a product that can prevent exposure to COVID-19 to make sure that user is free from COVID-19 symptoms, to alert the user from standing near each other so that the virus will not easily spread.
For the scope of project, Connected Visor can be in two sizes, which are adults and kids size. We have developed tools that allow us to protect ourselves and respect the preventive measure against COVID-19, composed of the ultrasonic sensors to measure the distance, an infrared thermometer to monitor its temperature, a LED and a piezoelectronic speaker to alert guide the user, a Bluetooth module to connect the visor to its mobile application. By placing our hand 10 cm from the visor for the 10 seconds, the visor automatically active a 20-second timer to help us wash our hands. This is for the hand washing timer. The mobile application allow you to display the measured body temperature on the forehead of the person wearing the visor. To active or deactivate the following function, which is hand washing timer and mute mode. For literature review, we have two. The first is face shield, a normal visor we call a face shield. A face shield is an item of personal protective equipment, PPE, aims to protect the wearer from the hazard such as flying objects and the road debris, chemical splash or potentially infectious material. Depending on the types used, a face shield may protect the wearer from a physical hazard, energy or radiation, chemical splash or biological hazard. Next, number 2, face shield from headlamps. The use of the face shield in hospital has become normal practice as a result of the current COVID-19. The use of PPE has created various obstacles from ENT surgeons. The biggest difficulty that ENT surgeons encounter is sight, particularly peripheral aberrations, which is hampered by the eyes protection goggles. To reassure the ENT surgeons, they propose the adoption of the customized face shield as a solution to the present challenge encountered in the operating rooms during complex operating requiring PPE and headlights at the same time.
Assalamualaikum, my name is Daniel Izzuddin bin Hanafi, CE 210-210. We present about methodology of our project. The project implementation are based on block diagram in figure 1 and flowchart in figure 2 below. So for the block diagram, for the input, we put the LED, ultrasonic sensor and infrared thermometer. For the microcontroller, we put the Arduino Nano R3. For the output, we use the Bluetooth module and piezoelectric speaker. And for the flowchart, from the start, we check the visor. If the visor okay, then we check the MIT apps at the phone. If Bluetooth and all button is on, then we can connect the phone with the visor to display temperature. And we should know that the buzzer is on, so the sound of the buzzer can tell us the distance notification. For the expected outcomes in the fight against COVID-19, we recommend the following preventive measures, such as wash hand regularly, do not touch the face, and keep a social distance at least 1 meter from each other. And the second is the thermometer sensor is placed 2 cm from the forehead, and the distance sensor is placed in front of the visor. And lastly is the user will be able to protect their face, keep a social distance of 1 meter with the others, wash hand properly, and monitor their body temperature always.
This is schematic circuit for the connector visor. We use battery 9V, wire red connect to on off button, black wire connect to ground, MLX 90614, the red color connect EVE, black color connect ground, the yellow color connect at A4, and the green color connect at A5. Then HC05, the first RXD connect at D10, TXD connect at D11, ground connect to piezo speaker, LED ray, and HCSR04. VCC connect to HCSR04 VCC and 5V. Piezo speaker, the orange color connect at D6. LED red orange color connect at D5, and the last for HCSR04, blue color connect to D4, orange color connect to D3, and the last black color connect to ground.
This is the design application mobile. We use MIT inverter design. There are 5 display screen and 2 buttons, which is the temperature display and the button of hand washing, alarm, and silent mode.
For the calculation of the project, we made a calculation for ultrasonic sensor. The speed of sound of ultrasonic sensor is 340 milliseconds. So we change the millisecond to centisecond, from 340 milliseconds to 0.034 centisecond. For the time, we need to divide distance with speed. The distance is 10 cm from the ultrasonic sensor to the object. Divide by 0.03 centisecond. We get the value is 294 microsecond for the time. So for distance, we need to multiply the time and speed and divide it by 2. So 0.034 centisecond we multiply with 294 microsecond and divide by 2, we got the value is 5 micrometer for the distance.